Today, I want to revisit the topic of finding the size of a file because I think there's more to say about it. Welcome back, friends. Today I want to talk about how we get the size of a file. This is something that I talked about earlier, but I want to revisit it, and I'd really like to know your opinions. As I mentioned, I talked about this in a previous video way back in 2018, and in that video, I talked about using stat and fstat as a way on POSIX-compliant operating systems to get the size of a file. But I've had a few comments, specifically a recent comment by David on that video that made me think there's probably more to say here. Today's video is sponsored by, well, you. Specifically, all of you wonderful people on Patreon who support this channel. People like Jacqueline Peacock, Joseph Taft, and Jeremy Matthews who support this channel and help us keep things moving in the right direction. Thank you. Now let's talk about file sizes. So in my previous video on the topic, I showed you one way to get the size of a file. Well, really two ways, but they're variations on the same way, and that was stat and fstat. Today, I want to compare that approach with the one that David suggested in his comment, that is using fseek and ftell, because I think that it's an interesting comparison, because it's one of those instances where things get a little tricky and it may not be clear necessarily what the right answer is. So let's try to look at them both side by side. So what I want to do for this video is I want to have a function, we'll have it return a long. We'll make the function called getFileSize, and I'm going to say getFileSize1 because we're going to have two different versions, and we take a file name, okay? And we're going to make two versions of this. Let me just make a second one down here, and it's going to be getFileSize2. Okay, now the first one is basically what I showed you in the past, okay? It is where we get a struct stat, so this is a specific struct that is created for stat, and we'll call it we'll call this file status. And then let's call stat with our file name and the address of our file status. And if that returns something -1 probably, but if it returns anything less than 0, we know that we had an error. Okay, so in this case, I'm just going to return result error. Notice that I pound defined this up here. It's basically just going to return a -1 if we have an error. Then if we didn't have an error, we're going to come down here and return file status.size, and this is going to return the size of our file. So nothing too complicated here. Now let's look at the other approach that you're going to see. For this approach, we want our function is going to look exactly the same. We're passing in a file name, we're getting a long back, so nothing strange there. But this time what I'm going to do is instead, I'm going to basically open the file. So we're going to call fopen with our file name. We're going to open it in read mode. And then we need to check if that file pointer is null, then we're going to return result error, okay? Just like before, if we have an error, we're gonna return it. And then we're going to say if fseek, okay? So we're gonna call fseek. Some of you may not have seen this before, but this basically allows us to set the read or write position for our file. So we're going to seek 0 bytes from the end of our file like this. Now, if that returns negative number, again, if that returns an error, then, well, we got a problem here. So what we're gonna do is let's close our file just to clean up, and we will return again result error, meaning that we can't get to the end. And let me not forget my F right there. Okay, so then once we get down here, now we know we've been able to seek to the end. Now what I'm going to do is say, let's make a length variable, set it equal to ftell f. So what this is going to do is going to actually get us the position in the file, and then we'll call fclose on f. This is why I actually saved it in a variable rather than just returning it, is that I wanted to be able to close the file before we're done, and then we just return length. Okay, so these are our two different approaches that we're looking at today. Now, let's call these functions, let's actually use them, make sure they work. So let's come down to main here. And in main, what I wanna do is first, well, let's actually get the file name from our arguments, from our argv array. So here, I'm just going to really quick check to see if argc is less than 2. If it is, then they didn't give us an argument, and I'm just going to print f, a little bit of a usage string here. Let's printf s and then a file name here and a new line, and then argv0. So this is basically just telling them, here's how you're going to run this thing, and let's return exit failure in this case because they did not use it correctly. Okay, so this is just basically to make sure that someone actually provided me with a file name or some kind of argument that I'm going to interpret as a file name. So that's not strictly necessary, but it helps make things cleaner if I run the program incorrectly. And then let's just come down and get a file name pointer, and I'm going to set this equal to argv1. Now, this, of course, is not necessary. I could have just basically passed in argv1 everywhere, but I think this makes my code a little more readable, so I'm going to go with it. And then let's just come down here and actually get the length of the file. Let's print out, we're going to say the file name here, and then let's put a tab character, and then let's print out 2 of these sizes. Like this, and then a new line. Okay, so it's basically going to be the name of the file and then 2 sizes, one using each of our different approaches. And then we'll come down here and say file name, and then get file size 1, pass in file name, and then get file size 2, file name. Now we're wrapping lines here, which is kind of ugly. Don't really like that. So we'll just kind of make things line up a little bit better there. That's nice. Okay. So now we have, let's also return exit success. Okay, great. So now we have our main. That's great. Also note that I do have a simple makefile over here. Nothing fancy. It just compiles my file sizes program using Clang. Nothing fancy here. But so now we can compile it. Okay, great. We haven't inserted any weird bugs and forget any closing parentheses. And now if I run it, well, you notice first, if I run it without arguments, you can see that it complains. This is how we wanted it to work. And then let's just say, why don't we just use our file sizes program? So we'll just see what the size of that is. And you can see we get 2 different sizes, 50,200. If I look in here, you can see 50,200 is in fact what the size of this file is. Okay, so things are working. But the question is which one is best? And this is where I get a little, well, I go back and forth. There are pros and cons of each, and I just want to talk about them. So let's start with the first one. The first one I like because it's shorter. Shorter is always good as long as you don't lose clarity. And also I think this one is more to the point. I think it's clearer. When I look at this code, it's really clear to me what it's doing. And hopefully it's also clear to the compiler what it's doing. You know, when I call stat, I want information, status information about a file. And so that's really good. The operating system knows exactly what this function is doing. That's also good. And I think this is a good opportunity to just mention just a general software design thing. A good piece of advice is that it's always good when the intent of your program is obvious to your tools, your operating system, and any other systems that you are interfacing with or interacting with, because this allows them to make things faster, and if they know what you're doing, they can help you out. It's almost always a good thing. And this is why in that first video, I showed you this method. So what is its downside? Well, basically the downside of this approach is that it's not very portable. So stat is part of the POSIX standard, so it's going to be available on any of your POSIX compliant systems like Linux or Mac OS, but it might not be available elsewhere. Someone out there who has actually written much Windows software in the last 5 to 10 years, please correct me here. But last I checked, Windows has their own specific functions for this. So if I want to write code to get file sizes and I want it to run on basically any machine out there, this alone isn't going to be enough. I'm going to have some checks in here to see if I'm on a POSIX compliant system. And if not, then I'm going to need to provide an alternate implementation. And maybe that's a pain. So that brings us to option number 2. So the second approach has always felt a bit broken to me. When I read it, it's not obvious what's going on. I'm opening a file, which maybe I'm thinking, am I going to read this file? I'm moving the read position to the end, and then I'm getting that position. And so like by the time I process it all, you go, okay, I get what you did there. You got the length, but it feels kind of convoluted, and I don't expect someone who sees this code right off the bat to understand what is going on. And while it's not obvious to a reader, it's probably also not obvious to your OS. They might see you call fopen, they see you open this file, and your OS might try to do something clever, like start prefetching a bunch of data from this file because it thinks you're gonna read from this. I wanna quickly grab some of that data and make things faster. And in the end, that effort might be totally wasted because maybe we don't wanna read this at all. We just wanna know what the size is. Now, the upside that I always hear people claim with this approach is that fopen, fseek, ftell, and fclose are all part of the C standard library, specifically ISO C90, and should therefore be available on just about any system with a fully implemented C standard library. So yes, Windows people are excited. Finally, they get to play, but not so fast. Seriously, you thought that old Microsoft would make it that easy, but no. There are a few things to watch out for. For example, way back in the day, someone thought it would be a good idea to treat text files and binary files differently. And this, of course, was due to the line ending nonsense that I've mentioned in other videos. But the consequence is that if you look at the fseek documentation for Windows, you see nonsense like this. See, it turns out that fseek doesn't really work well on Windows if you open the stream in text mode. Oh goody. Fortunately, we do have control over how we open the file, so maybe we can just come up here and add a B, and we can just force it to always open the file in binary mode. Now, of course, POSIX compliant systems treat all files, text or binary, the exact same, which frankly just makes sense. You hear me, William? One other warning about this approach, and that is that if you take this code over to C++, then things are complicated over there too. So if I look at the C++ documentation for fseek, we see that, well, library implementations are allowed to not meaningfully support seek, and therefore code using it has no real standard portability. Well, thanks, C++. So the portability story is definitely fogging up a bit here. Also, as an aside, if you are working in C++, the story stays about the same with the first option. It will work as long as you're on a POSIX compliant operating system. And keep in mind that there's another approach here. So let's say I'm just going to come in here and let's make another one, because we say that this last one isn't guaranteed to actually work in C++. So there is another option here, and that is we could just say, and keep in mind that I'm assuming here that we're in C++, we'll handle that in a minute, but I can just include fstream, and then down here, we can simply just do something like this. We can make an fstream called, we'll call it infile, why not? And then pass in our file name and ifstream ate, that means we're gonna open it at the end. And then let's also, again, we have the same binary restrictions that we had before. So ifstream binary, realize I forgot a colon here. Okay, so this is gonna open that file, opening it at the end. So this takes care of the fseek. We're basically doing that same thing. And then we can return infile.tellg. So this is basically just the C++ version of what we saw down below. So like I mentioned as we were going, this suffers from all of the obvious problems that we had before. It is nice, it's a bit shorter. Maybe it's a little cleaner. All the colons and STDs everywhere, a little tricky, but it should be portable across C++ implementations, which is really nice. Also, this of course is going to be a little tricky because I have two functions with the same name. Why I did that is then I can just come in here and we're going to say if def C++. So we can check here to see if we're compiling with C++, and then down here. So if we're in C++, we'll use this one. Else, we will use this one. Okay, so you can see it shades this out because it's assuming that I'm not using C++, but later I will. And this just allows me, so I can still compile it, it's fine. I can also take this down here and also come down here and just compile it with C++. Now it is gonna give me a warning here because it's saying this is a .c file, which you're compiling as C++, and is that a good idea? No, it's deprecated, but that's okay. We're gonna do it for today because I don't necessarily wanna change the file name. But in this case, now I have now we're using C++, and if I say file sizes as well, then you can see it's working here as well. Now you notice the file size changed, that's okay. The reason is that we're using C++ and we just included a whole bunch of additional code. So anyway, that's a topic for another day. But yeah, the point is both of these work. And like I said before, I'm really not sure which one I prefer. For most of my C programs, I'm not so worried about portability these days. These are my current projects. So right now, I probably prefer the stat method, but portability is also nice as long as you steer clear of the issues that I mentioned. Mostly, I think this is a case where there is an obvious need for fixing some standards. It's not like getting the size of a file is all that different across systems, but for some reason people didn't think to include it in the original C standards. And frankly, now it's a little bit frustrating because in my opinion, this doesn't need to be this complicated. So let me know what you think down in the comments. Subscribe to the channel so you don't miss future videos, and until next week, I'll see you later.